Hi. So today we're going to be talking about searching the world computer. I'm Ren. I'm an engineer at Electric Capital. We're a crypto native VC fund that is building public goods in the crypto space.
Hey guys, I'm Gary. I'm also an engineer at Electric Capital.
Today we're going to share some lessons from building code search as a public good for Ethereum. One of the views that we have is that Ethereum is most likely on its way to become the largest open source ecosystem, but that comes with increasing complexity and challenges. What do I mean by this? We're going to look at a few metrics that highlight the scope of this problem. One of the interesting trends that we've seen over the past few years is that the quantity of code on Ethereum in terms of the deployed smart contracts has increased exponentially. For instance, the number of verified contracts on Ethereum has increased 5x since 2020. In terms of what users want, most users want transparency, because if you're custodying your assets in a DeFi protocol or trading an NFT, it's very scary to do that if the contract is not verified and is a black box. So one thing that we see is that around 70% of usage on Ethereum goes through verified contracts. And that's why being able to have transparency around verified contracts is important. But in terms of the magnitude of this code base, let's try and put it in context of some of the largest code bases that exist in the world. So today, Ethereum's deployed smart contracts has roughly 290 million lines of code, making it comparable to some of the largest software stacks in the world. It's comparable to the software in your car, Debian 5.0, and even larger than Facebook's stack. But the quantity of the code is not the only thing to highlight. One key aspect is that smart contract complexity is increasing. So one way to take a look at this is to see what the average transaction looks like. In 2017, the average transaction was making roughly 1.5 other contract calls. That number today has gone up to 5.5. That's a 3.3x increase since 2017. And another marker of code complexity is as programs become more complicated, they demand more storage reads and storage writes. So since 2017, we've seen that around storage reads and storage writes has increased 4.1x in a similar trend with increasing contract calls. One of the things we've done over the past quarter has been talking to different developers in the crypto ecosystem and trying to get a sense of what their development lifecycle looks like and where we can build a public good that adds some benefit and saves some time in their day-to-day process. So the average developer lifecycle looks something like this. A developer initially starts researching a topic. It could be a protocol that they want to implement. It could be new mechanism design, but there is some form of research process. Once that idea is kind of like solidified, they go through and they start the development process, a testing process, and a deployment process. One of the common pain points that developers in the crypto ecosystem have mentioned is the difficulty of researching and having visibility and transparency on the corpus of work that developers have already implemented over the past few years. And one of the major issues with using GitHub search for developers is that the versions of code that they're finding are not actually the versions of the smart contracts that are deployed on chain. And this creates a lot of complexity in terms of being able to tie out what code is actually being run in production. So over the past few months, we've kind of realized that as the verified code base has been growing exponentially, and there is now this massive corpus of work that developers are able to build upon and to reference and to learn from. And as we see the transaction and code complexity increasing, we realized there needed to be increased transparency through a public good that users can use for free. And that's why we decided to build code search as a public good for Ethereum. Our app is called Codeslaw.app. It's a bit of a meme on Codeslaw. And it's live today and free for everyone to use and in an ongoing manner. So let's put ourselves in the shoes of a smart contract developer and think about what they might want to search for. So here, you might think of someone who's an integration engineer working at a protocol or a MEV searcher, and they're curious about learning about code references to a Uniswap v3 pool. In Solidity, developers commonly use interfaces to interact with other contracts that are deployed on-chain. So one common example that they might search for is, what are all of the instances where iUniswap v3 pool is implemented and called on? So we can kind of see that once we run the search, the top result is more or less what we expected, which is the Uniswap universal router. And say we keep scrolling down and we find a contract that kind of is pretty interesting for us, and we can click in. So this is a Tornado router, and we're kind of curious about how they're using iUniswap v3 pool. And when we click in, it jumps into where the interface is being called in the code. And in this instance, Tornado Cash is using it for a time-weighted average price that they're using for their Oracle. Another powerful use case is a lot of developers, as they're learning Solidity, for handling numbers in Solidity is very different than handling numbers in a lot of other languages. So say you've heard about a library such as PRBMath, and you're curious about how other developers are implementing it and using it in production. You can search GitHub for this, but you're not going to get any results that match with the smart contracts that are actually deployed on-chain. So again, we can use a search such as library PRBMath ***, which denotes a wildcard search. So we're going to find all cases where PRBMath is being used, where the library PRBMath is being used. So again, we get some search results. We find an interesting contract that we've heard about. So Clipper, for example, is an exchange that is providing users with cheap execution costs for trades under $50,000. And we're kind of curious about how they're using this PRBMath library. We click in, and we see the library being imported. And as we're able to scroll through the contract, we see that they're using PRBMath for their int256, which, if I'm a developer, maybe I might consider using it as well.
Another great use case for Codeslaw is trying to understand the composability of some contracts on chain. And so what I mean by that is you can find references that one contract will make directly to another contract. And so we can do that by searching directly just for an address. And so maybe you're like a DAI maxi, or you're just curious about where DAI is being integrated. And so what we can do is search for the DAI address. And then what we'll get is a bunch of results where the DAI address is hard-coded. And so we kind of get some interesting ones here. The first one is an Aave monitor, and so that's from DeFi Saver. The second is like a Aave improvement protocol to wind down Aave Fei. But let's click into the first one. So same as before, we're able to go straight to the reference and dig into the code and do some investigation and figure out what's going on here. One thing to note is that at some point we want to integrate bytecode as well as storage data that is not constants. And so what that will give you is the ability to search over the storage values as well. So and in that world, this query for an address will actually pull up a ton more results where users have manually inputted the address. And the last use case that we think is super powerful is to explore the code base for vulnerable contracts. And so let's say you're a security researcher and you just came across news about the Nomad Bridge hack. If you look at the breakdown of what some of these firms put out, they break down into the code and point out the exact lines. And so you have this function, acceptable root, which is the source of the vulnerability. And on Codeslaw, what you can do is you can search for the function signature. And what that's going to do is going to pull up a bunch of contracts that also implement that function signature. And you can reasonably expect that they're implementing the same logic. And so after searching that, Codeslaw gives us 38 results. And so what we can do is kind of scroll through, click into the results, if you're a researcher, dig into the logic and see if these other implementations are susceptible to the vulnerability. And if you find something that's susceptible, you probably want to notify the team that is responsible for that contract. And so that's some of the use cases for Codeslaw. Definitely as we build out more features, the power of it will grow. But what I want to get into next is a little bit about how we built it. And so essentially, code search is like a search engine over source code. And so a naive implementation to solve this problem would just be to run grep over every single file. But that's a pretty inefficient brute force solution. And so to solve this, we can employ a two-step process. And so that involves pre-processing our data and then running some sort of query algorithm on the data. And so the state of the art for doing code search is kind of pioneered by Google, early 2000s, and they use a trigram index. And so essentially that's a data structure that maps 3-letter strings back to some document ID. And so what I mean by that is I can demonstrate that here with this toy example where we have these two documents. They're kind of short lines here, but essentially you go through each 3-letter string, every 3 letters in the text, and you note that that 3-letter string appears in that document. And so by the end of it, you end up with this big lookup table of 3-letter strings mapping to a list of documents. And then in the querying process, before I go on, in the indexing process, we also score the contracts to cut down on searching for junky contracts or just ranking the results to serve you better results. And so some of the signals that we put into that scoring is the biggest one is transaction activity. With blockchains, there's not a lot of spam. And so if a contract has a high transaction activity, you can sort of trust that it's high quality because people are willing to spend money to interact with it. And there's some other signals we use, such as deployer score. If a deployer is known for deploying good contracts, and then also if a contract is forked commonly, then that's probably a pretty good contract. And so for the querying process, what that involves is you take your query and you extract the trigrams from the query, and then you go to your lookup table and you pull out each list of documents that corresponds to each of those trigrams, and then you return the intersection of all of the documents. And so you basically want to find the files that contain all the trigrams. And then some of the other boring parts, I guess, of the app is just the data processing pipeline and then the app itself. So the data pipeline, kind of what we do is whenever an account goes active on Ethereum, we put it into the pipeline. And if it's a contract account, then we'll put it into a bunch of stages and extract information from the blockchain and various sources about the contract. And then the web app itself is a pretty standard modern web stack. We use Next.js, React, Postgres, Tailwind. And the last part we want to talk about is the roadmap for Codeslaw and some of the things that we're thinking about for the future. And so the first one I want to talk about is peering into contract storage. And so this is interesting because if you're familiar with how Solidity is built, for example, there's a notion of private variables, and these variables are not easily exposed at the top level for users. And so what you can do to extract the private variable values is reconstruct what the layout of the storage should be, and you can do this by using the original source code, and then you can query specifically for the data at those storage slots. And so we're hoping to get that out soon. And the second thing that we're super excited about is featuring annotations on contracts. And so, what I have here is a screenshot from this website called Rap Genius, which is a website where you can look up song lyrics, and the community can annotate the lyrics and explain what they mean. And this example specifically is an annotation directly from the musician. And so you can imagine on Codeslaw, if you go to your favorite contract and you're, or a new contract that you're trying to figure out and learn, you don't have to do 100% of the work of learning it from scratch. You can dig into the annotations that the community has provided and jumpstart your learning. And it would be also really cool if you could, see a protocol's account that's signed off on an annotation, much like this example over here. And then, just also some other features and improvements is just always trying to improve the search quality and the efficiency, adding more powerful filtering and sorting, and then also dark mode, which is a highly requested feature. So yeah, that wraps up our talk. We'd love for everyone here to check out Codeslaw and give us some feedback and provide us with any feature requests you might have. Thank you.